Well, good afternoon, good morning, or good evening, depending upon where you are in the world, and welcome to today's DevOps.com webinar. I'm Charlene O'Hanlon, moderator for today's event, and I welcome you. As always, we have a great webinar on tap, but before we get started, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you miss any or all of the event, you'll be able to access it later on. Following today's webinar, we will be sending out an email that contains a link to access the webinar on demand. And we are taking questions from the audience. So if at any time during today's presentation you have a question for our speaker, please don't wait, don't hesitate, just use your GoToWebinar control panel and submit your question, and we'll get to as many as we can before the end of today's webinar. And also at the end of today's webinar, we will be doing a drawing for 3 $50 Amazon gift cards. So stick around, hopefully you'll be one of our lucky winners. Okay, with that, let's go ahead and kick off today's webinar, which is how to identify hard-coded secrets in software. Our speaker today is Arun Balakrishnan, who is Director of Products at Shift Left. Welcome, Arun. Thank you very much for joining me today.
Thank you so much. Hello, everyone, and welcome to the webinar. Thank you for joining. So, yeah, as the introduction said, we are going to be looking at how do we identify hard-coded secrets in source code. I'm from Shift Left, and I'm a Director of Products here. The problem statement is not new. On the screen, you can see news reports going way back to 2015 and as recent as late last year. A lot of breaches, a lot of issues when organizations leave what could be classified as sensitive information, authentication credentials, secret keys, these could be API keys, all in source code. And most often, the source code might be, say, in a public repository. People might get hold of it. And this one single string could be the key to your entire organization, to your entire infrastructure. Right? So what might look like a benign set of 16, 18, 20 characters could open the doors to everything that you're trying to protect from the bad guys. So this is not a new problem, and this is not a problem that's been fully solved yet. Now, what does this look like in your source code? So there's multiple forms that it could exist in. One is the straightforward example that we put in the top of that slide, wherein you're literally hard coding it in your source code. This example is like an access key. It could be a secret key. These could be, as I said, used to access infrastructure, access APIs. These could be private keys that encrypt something. So this could be directly hard-coded in your source code, so what we call as literals. And they are then used as a variable name, right? So in this example, like the access key ID, the secret key is what you would then reference within your application. You could do it by calling methods, wherein you call something, you've done a get property, then you're getting it into a variable. So these are used within the source code, but these are being moved around the application, right? So it is still within the application. And then it could be something like this, where you're getting it from a vault, and then you're storing it in a variable, and then you start using these variables. So this is where you define them. This is how you would use them and pass them around. And this is an example on the bottom where it ends up in what we call as an untrusted sink. In this example, it's a log file. So as part of, say, maybe debugging the application or trying to figure out if this application is doing what it's intended to, the developer might write it into a log file. So there's a lot of implications here where we don't know where this log file resides. Is it encrypted at rest? Is there some redaction that is happening? So none of that is evident by just looking at this line of code. And so this is one way of how it could be in the source code. This also the second level where it is user defined. So here, for example, it's a bit more involved. So you have a class, you have something that is referencing to it, you're like instantiating something, it's getting assigned to variables in the class as part of the constructor. And then at the end of the day, it's again still ending up in a sync channel, which, as I mentioned on the previous slide, could be sensitive, could not be encrypted, so it could fall into the wrong hands. Right, so it's two types as I defined. It could be a literal, it could be also user-defined, it could also be moving around within your application. So to get a better idea of what developers are seeing this in a day-to-day basis, we did a survey. It's still ongoing, but I wanted to summarize it as to what the state is till yesterday. So we've got 52 respondents to our survey so far across 33 organizations, a lot of them big names here in the Bay Area and also across the world. And the participants in the survey were primarily in the development roles, so engineers, dev managers, architects. So people who are very close to applications, very close to source code, who deal with this day in, day out. And the question we primarily ask them is, what kind of hard-coded secrets and literals do you see in your source code on a day-to-day basis? And this was the response. Note, they don't add up to 52 because people would have responded to more than one. And what you see here is a summarization of that. So the primary suspect that we had and which held true after the survey is all these cloud keys and tokens, even usernames and passwords being directly hard-coded. There might be flags that they put in saying, hey, if this is in staging environment, let this be part of the application, and production, take it out. But that doesn't mean that it goes away from the source code. It might go away from the application build, but the source code still is the source of truth. So it still is there in the repository. Right? So all of these strings are what they see on a day-to-day basis within the source code. Things like URLs and stuff are just questionable source code where it might reveal internal URLs, it might reveal URLs that you don't want to be exposed. It's not exactly serious, but there are better ways of managing it rather than hard coding it into the source code. But things like, say, IAM keys and API keys, even like connection strings, including credentials, those definitely have no purpose of being directly in the source code. Right? So this was from the survey. And then we also asked them, okay, so if not in the source code, what would you recommend, or what do you guys do today? So it's just a word cloud based on responses. Couple of primary things that stood out. One is, yes, there's a clear consensus among the participants saying, yeah, there's no reason secrets should be there directly in the source code, right? So that is one, encrypted or otherwise, right? So because if you encrypt something and if the encryption key is in the source code, well, then that encryption doesn't make any sense. And then from a utility perspective as to how you could secure it, the word vault is the one that stood out the most, right? Softwares like CyberArk and 1Password and even encrypting it and checking it into the repository. So the file that's in the repository is fully encrypted and the key is kept somewhere else so that the file can be decrypted at runtime using a key that's coming in from a vault. There are other devices which we thought would be more popular but didn't show up much on the survey, things like HSM devices. So these are hardware devices that are put in, particularly true if you have your own data center, which are purpose-built for holding things like certificates and keys. Or if you were to use the cloud, yes, there are cloud HSM devices as well, or things like secure S3 bucket. A lot of CI/CD environments allow what they call as environment variables. they do two levels. One is, of course, since it's an environment variable, you cannot see what the value is. The CI/CD systems also ensure that they don't print it out. They would redact or mask it. So even if you were to get hold of the logs or the console output of the build, you would not be able to see the keys. And most of them also do one-time storage, wherein when you enter it, they show it to you, but then they would redact it. So even if you get admin usage into the CI system, there's no way to retrieve it back from there, right? So they would like mask it off so you can't see it. So that's again a common technique of ensuring that the secrets don't remain in the source code. Of course, I would love to hear feedback. So if you have any other methods that didn't show up, feel free to send them across in the chat window, the questions window. Would love to get your feedback as well. So this is from the secrets and the literals perspective. And there are many solutions out there who would help you look at these. Just putting literals in the source code is much easier to find because you're literally searching for patterns. So it's literally like grepping for something within your source code. It's an easier ask. The tougher ask is to see where are those literals being used? Are they actually being used? I mean, I could have a config file with a bunch of literals listed in them, but that doesn't mean that those are actually being used. So if I get a report saying, hey, you've got all these literals in your source code, I might be aware of all of them, so then they are like false positives. I'm more interested in knowing things that are being flowing through my application, going through transformations, and then seeing actually where they're being used. So that's one aspect. There's another aspect which is starting to be more important these days is sensitive data, right? So these are not actually literals. These are sensitive information that you're managing in your application. By that, I mean, say, usernames and PII data, payment information, healthcare information, depending on what industry your organization is involved in. And this is extremely difficult these days, given the scenario that is on the slide here. So on the right is an image, the representation of the network communication, the network topology of microservices at a big organization. So each dot in that is what they classify as a microservice or an application. And all those lines in between are the channels or paths of communication that exist between these applications. So you can imagine it literally is not possible manually to even track any of these flows. And you would need some kind of automation, some kind of tool that can go in, track all these flows, and help you figure out, okay, where is information coming in from, where all is it going, and where does it end up residing at the end of the day. So tracking, managing, gaining visibility into sensitive data is also critical. Now, you might say, okay, hey, I've got data encrypted at rest. I've got data encrypted in motion. Isn't that sufficient? So I've got like network level controls. Isn't that sufficient? So one is trying to figure out, okay, what is sensitive, right? So if there are two elements, X and Y, they might be not sensitive in their own respect, but then when it's being combined or when it is being used in a certain fashion within the application, that is when it might become sensitive, right? So you might have, say, a first name, which in itself is not sensitive. You might have another PII data, which also might not be sensitive on its own. But when you combine both of these, that might be enough to exactly identify who the individual is. So that then becomes PII data, which needs to be controlled and regulated. So just securing these two individual information on its own doesn't mean the combination by inherently is secure. So the network level controls or encrypting them at the rest level lack this kind of transitive information. The other thing is also saying that, hey, I always redact and obfuscate information before it goes into rest. Again, is losing track of where that information is actually being used, right? So in this graph, if I were to start on like the top left, where the information is coming into your application, it goes through all of these flows before it ends up into, say, your database or your blob storage or wherever you store that information, right? So unless you are aware of all of these tracks, you might be storing or obfuscating it before storing at the end, but you're not sure where else it might be leaking during those transformations. The last thing is also saying, okay, has all these transformations and obfuscations that you apply, are you applying it in the right way? Right? So again, it goes back to knowing the flow of information, wherein you might say, okay, I'm going to transform it or obfuscate it the last step before it goes into the log. But maybe there is a flow before that wherein a partner organization is using your APIs, or you're sending this information off to your marketing division for doing marketing campaigns, right? So you need to ensure that it's obfuscated or redacted before that as well, not just before it goes into rest, right? Because say for executing a marketing campaign, you might need information, but you don't need the entire thing. So you might need, say, demographic information, but you don't need complete PII data to do a campaign. So before that API call transmits that information, you should ensure it is getting redacted or secure. So we've looked at two broad categories. One is literals and secrets within your source code. We looked at various types of how it looks like and how it is used. And we also looked at sensitive information in your source code. Right? So what classifies as sensitive information, what controls that you can put in place, and why, say, network level controls in itself is not enough. So how do we go about discovering these in your application? So the first category is literals. As I mentioned, they are relatively straightforward to find out because they follow certain formats. They have certain patterns that you could look for. So like literally grepping for searching for within your application. A lot of repositories also might have that capability today, where they're literally looking for these patterns. So in case you check in code with something, they immediately say, hey, this looks like a key, so you shouldn't be putting it in your repo, right? So those are rather straightforward. You could do regex-based, you could do pattern-based. The other is the user-defined types and then predefined types. And so that gets more trickier, wherein how do I determine if something is sensitive data or not? But what we do at Shift Left is we have a natural language processing engine, which first helps identify where you might be storing and using the sensitive data. But that in itself is not enough. We need to also identify all the flows that it goes through. So that is all the read, write, and transformations that the data goes through. Transformations in general could be encryption, redaction. You might be escaping some data off in order to avoid, say, attack patterns in the data. Right? So that is what we need to look for. And then is the flow of the data. So like, where is it emanating from? So that we call as a source, all the transforms that it goes through, and where does it end up as a sink? Sinks could be of multiple types. As listed here, it could go into a log file. It could be, say, transmitted over emails or APIs. It could reside into a database or a storage of some means. It could be transmitted back over the network. So that API could be an example. It could be transmitted back to the user over HTTP or HTTPS. So you need to keep track of this entire thing so that you know where the sensitive data is, what is it going through, is it being secured properly. just to summarize what we have seen so far, so yeah, we looked at literals, we've looked at another category called sensitive data, we looked at issues that exist, what you would need to look for. On this slide, we looked at how some mechanisms work for both literals and for sensitive data. What I would like to do next is a quick demo of how the shift left solution works. For this demo, what I've done is I've got a source code repo on GitHub, and then I've integrated this into a CI system. I'm using Circle CI for this demo. And then as part of the CI system, I've also integrated the shift left solution. And that solution has been asked to look for sensitive data and for literals. Right? And then I'm integrating this into the pull request. So as soon as the developer makes a pull request, all of these checks are instantiated. And then it's looking for your entire application, right? So not just for the code change that you just made, it's looking across the whole source code. And then it pumps out a report into the pull request itself. Right? So let's see the demo right now. And as was mentioned in the beginning of the call, feel free to send us questions at any point. You don't have to wait for the end. So this repository here, so I've got we call it a tar pit. It's a demo application that we've created, and it is residing on GitHub. And what I'm going to do here is I'm going to edit this file. So this file it's a Java file. It's a Java project. It's called servlet tarpit. I'm editing this file here. I've commented out a line. So for now, the source code has an access ID key which is empty. This could be where it is maybe taking it from the vault. I'm going to uncomment this line. So what I've essentially done is I've hard-coded this access key into the repository right now, right? And then, of course, there are various other things also in the source code, like the secret key is there in the source code. This repository has other files as well, where there are sensitive data information. So like for here, you could see as an example, there's like a login, there's a password, there's this variable. We need to see where this variable is being used. You could see as an example here, this logger is logging the access key and the secret key. So this could be a straight ahead problem here where we don't know where this logger is going to. Right? So there's a bunch of issues that this source code has. So as a developer, what I would then do is I would create a pull request, right? So I'm proposing a file change. And I'm only making this file edit, so I'm going to create a pull request directly. Right? So now, as part of this pull request, as you can see, okay, I'm still on GitHub. It said, okay, I've created a pull request. I didn't give a comment for it. And it says, hey, GitHub is saying, I'm going to do some checks on your source code before I let you merge or send it for manual reviews. Right? Let's look at details of what is happening right there. So this is Circle CI. As I mentioned, that's the CI system I'm using for this demo. And here it's doing a bunch of steps. Right? So it's like spinning up a Docker container. It's checking out the source code. It's installing our shift left agent. It's installing our product. And then once the product is installed, it's also going to try to build the source code because if I'm introducing like a syntactical error and the build fails, well, there's no point even trying to see if the code is accurate. So it's building the application right now. And all of these things are not under our control because building takes as long as it takes for Maven to build it. So it's done that. It's getting some of the scripts that we've done. It's analyzing the source code for hard-coded literals. And then it's going to tell me whether it found something. It's going to write back into the pull request as well. Right? So we'll see that in live. And then there's multiple ways where I could cut down this time a lot. For instance, in this demo here, I'm getting the standard Docker container from Circle CI. I could create my own custom container, which already has some of these pre-installed, like where shift left is pre-installed, where our product is pre-installed. So we don't have to pull down and install the product each time. Right? And so it's analyzed it and it's asserted the build against what we identified as our security standards, and it's done. Right? So in a minute and 50 seconds, it did all of these. So just to reiterate, it brought up a standard Docker image in the CI system, checked out the source code from the Git repository, pulled in our agent, installed our solution, built the application, and then pulled out our policies, analyzed the application, and then gave us a result. Right? So all of that in a minute 50. And as I mentioned, this could be further brought down to less than a minute if you want to. There's a lot more optimizations that could be done. So going back to GitHub, so you see the icon has already been updated. It says the checks have failed. And if you see here, there's a bunch of comments that have already automatically come into the repository, into the pull request. So here it says, hey, this key, there is a hard-coded, excuse me, there's a hard-coded literal that was identified in the source code. Right, so that key came in here. It says, hey, this username is coming in from here. It is ending up in a sink that is sensitive. So that's a sensitive leak. Right? And these are just two examples that I've done. This actually spits out a full JSON file, which has all the output. I just wanted to show these two as an example. And here, if you were to click on this link, it directly takes me to that specific file in that specific repository. Right? So it actually did the previous. Yeah, it compared it against to the master because it said, okay, this is where the error is. And then here in this example, let's click on the pull request. Okay, so in this one again, I guess, yeah, there's a link here where it says, okay, on this is where that username is first assigned, and you can then track the flow. And here it says it ends up into a log file. Right? So this could be classified as a PII data. Right? So it's two examples of one a literal and one a sensitive data leak. As I mentioned, the JSON, the report gives you the full details of all the other things that you have found. Well, there's one more comment that just came in saying, hey, there's this username that is being used in this file on line number 26, which is again going in via the logger. Right? So this is a quick example of how we identify literals and sensitive information. One thing to note here is that it just didn't say the username is sensitive, because then there would be a lot of false positives. It says this is sensitive because we are identifying it in a flow which ends up in a sink which we deem as sensitive. Right? So it's because of the flow, not just because of the variable or the value that it contains. So this is a quick example. Let me go back to the presentation. So yeah, so this is the example that you saw. The detail that I mentioned is available on our cloud dashboard. So this is the shift left inspect product, where you would see the full detail, right? So this is just the pull request comment, but as a developer, you would be interested in seeing the full detail of how that flow happens. So this is the view that we provide, where on our UI, you would see the complete data flow, where it starts, the variable, all the transformations that it would go through, and where it is ending up in a logger, right? So in this example, in this particular route is where and then the vulnerability route is where it ends up into the logging. And it's complete details, so including line number and source code file. So as a developer, you could figure out, okay, hey, do I need this to write into a log file? And yes, if it is required, in this flow, is there a place where I can put in a control? It could be, say, a redaction, an encryption, depending on what your use case is. Like if you're using this, as I said, for like a marketing campaign, encrypting it wouldn't help. You might want to redact it. So it becomes non-PII, but it's good enough for executing a campaign. Or if it is being used for like debugging purposes and it has to be in a log file with full details, well, then encrypting it would be an option. Right? So it's up to you as an organization to decide what kind of control you put in this flow. Right? So the product that was used here is shift left inspect. We have a free offering on our website. It's shiftleft.io. And if you go into shiftleft.io/register, you would see a page like this, where you can sign up for a free version. What does the free version come with? We allow unlimited scans, unlimited concurrent scans, unlimited frameworks, and we support any of these languages. It's completely free. You can do up to unlimited concurrent scans, but up to 300 scans per app per year. You can scan up to 200,000 lines of code in a year as well. And we are extremely fast. So as you saw, it took less than 2 minutes. As I said, you could further optimize it to be less than a minute to do all of those steps. And in our benchmarks, we can do up to 1 million lines of code in less than 15 minutes. And what you saw is just the sensitive data leak and hard-coded literals. But we do technical vulnerabilities and other vulnerabilities as well. So like OWASP top 10, SANS top 25. As you saw, it was completely integrated into the pull request. The developer literally didn't have to ask for a scan or initiate a scan. It was all completely integrated, fully automated. No human intervention required anywhere. So that's what we call as pull request integration. And for this demo, I use GitHub and CircleCI. That doesn't mean it doesn't integrate with other systems. So Jenkins or Bamboo or Travis or in any of the CI/CD systems, Azure DevOps, any of those. It doesn't again matter if it's on-prem or cloud, and also any of your repositories. It easily integrates into any system. So yeah, this is anybody can sign up. So feel free to visit this link and sign yourself up for a free version. And to summarize, before I open for questions, what we saw today was hard-coded secrets, literals, and sensitive data in your source code. So yeah, it is a real problem. There's been multiple breaches around this. So watch out for them, get a solution that would help you find them, secure them, and help you not be infiltrated. And a simple, direct, little pattern matching solution is a start, but that doesn't solve for everything. One, it could lead to a lot of false positives. And second, it doesn't understand all the flows. And it definitely doesn't help with sensitive data. It could help a bit with hard-coded literals. And the example I showed you, the sensitive data, is already there in our product. In the free version, you can start using it today. It shows up in our dashboard as well. The hard-coded literals, the demo I showed you is an internal version. It will be also soon in the shift left inspect product, wherein you can do that hard-coded literal tracking. And as I mentioned, we have a free version, so please do sign up. The URL is shiftleft.io/register. So that's the presentation. We are open for questions. And thank you again for your time so far.
Yes. So if you do have a question for Arun, go ahead and use your GoToWebinar control panel. and put your question in. And why don't we go ahead and get started with the first one here. Let's see, does this kind of analysis work with HTTPS in addition to HTTP? And how about other protocols?
Sure, yes. So we work off the source code directly, right? So we are looking for things in your application, not when your application is running in runtime. So yes, there is an issue if we are trying to do a runtime solution where, yes, you're working over HTTPS and your traffic is encrypted, then we would not be able to see what is in those packets unless we become a man in the middle. But yeah, no, we are not looking for these things in runtime. We are looking for these directly in your application source code. So yeah, we don't have to do any of the network tricks or any of those. It's much easier and it's much more comprehensive in the way that we approach the problem. Yeah.
All right, excellent. Next question here. I'm interested to know if these methods are usable to find hard-coded secrets in DevOps platforms like Chef scripts.
Sure. So yes, so those are configuration things which we also can look for. We primarily look for the application source code. So we are looking for the source code, the flow, and then if the application is then reading these from the Chef scripts as a variable and then using them, yes, those are possible. And then the scripts that we have are all user or customer editable. So those can be expanded to involve anything. So we already do support configuration checks. So yeah, they can easily be expanded to your custom configuration files as well if you need to. Yeah.
Excellent. Okay, great. Next question. Let's see. Is this a SaaS solution or does it work offline or on-prem or?
Correct. So the Inspect product, the Shift-Left Inspect product that you can sign up for free is a SaaS solution. And let me explain what part of that is SaaS. So the source code of your application never leaves your premises. What we do is we put in, or you put in an agent. It's not even an agent, it's a command line tool of Shift-Left. You integrate that into your CI/CD system, wherever that may be. It could be completely on-prem. And we create what we call as a graph representation of your application. Think of it like a metadata, which is what is sent to our SaaS platform for analysis. Right? So the source code as such, the repository as such, never leaves your premises. Those could be completely offline, on-prem, and it doesn't matter. The inspect, the dashboard, and what you log in to see the results, that part is SaaS and is hosted by us. But at the same time, we are SOC 2 Type 2 compliant. We have all those compliance measures in place. So even if it's only metadata, even those, we have all the controls and encryptions and everything in place to protect it further.
Excellent. Okay, great. Our next question, how does the SaaS application work with a repos with a repos behind a firewall?
Yeah, good question. So as I mentioned, the repo could be behind a firewall. It could be completely on-prem, completely offline. We really don't care. What we do care for is you integrating the Shift-Left command line utility into the CI system, and that then generates the metadata, the graph, which needs to be sent back. And that is a push out, so there is no incoming traffic ever into your premises from our SaaS platform. This is something where you would, it's an outgoing connection that pushes the metadata back to our SaaS. And that's the only thing that you need to open up. Our SaaS runs on AWS cloud environments today, so most of those domains might be whitelisted in most companies. But again, it's an outgoing connection. There's no incoming connection. And for that reason, yeah, your repo could be completely offline and it doesn't matter. It will still work.
Okay, excellent. Let's see. Next question: does data like access key and secrets get sent back to the Shift-Left SaaS platform?
Yes, good question. So the way it works today, when we create into a graph, we need to know where that information is flowing, right? So what we do with customers today is when such information comes to us, one, of course, they see it for themselves in the first place. Second is if they are not looking at these, we have a responsible disclosure policy to these customers so that these customers are aware that these things exist in the source code. And then, as I mentioned, we have our own compliance and everything in place to ensure that we are not the ones that would then end up leaking this information. Right? So yeah, that's how we work.
Okay. All right, great. Plenty of time, guys, for questions. So if you do have a question for Arun, please go ahead and use your GoToWebinar control panel and submit your question. Next question, what is the timeline to release the hard code values data flow feature?
Excellent. So yes, so we have it in preview mode today. There's still some more validations and checks that we need to do before we make it generally available. But that doesn't mean that nobody is using it. We have customers, both paid and free customers that we are privately working with who have access to this feature. So if it is of immediate need, please do reach out. There's a chat window, there's a way to communicate, there's a contact us button on the website, and we would love to give you early access and get you on to use that feature.
Okay. All right, great. Well, let's see. Our next question here. What if my variable names aren't detected by the semantic/NLP?
Yes. So our NLP engine works off a dictionary that is made editable by the customer, right? So in the US domain, something like a social security number makes sense. And I understand it might be something very different in other geographies. So in our dictionary, we've covered for all the usual suspects. And that dictionary is continuously edited and updated by our team. And that dictionary, as I said, is editable by the customer. So the customer can edit, modify, remove, or add things to the dictionary. So these could be, say, I'm in a specific industry where I deem something as sensitive and I need to add it. So you are free to do that. Or what I have in or what Shift-Left has in the dictionary today doesn't apply to me. So that then becomes a false positive for me. So I have options to remove it or modify it. So that dictionary is completely editable by the customer, and that's how you would add your own variables.
Okay. Next question. My team releases daily. How quickly can you detect new leakages?
Oh, yes. So yeah, we have customers who release multiple times a day. We here at Shift-Left also do the same. And as I showed you in the demo, we integrate directly into a pull request. It doesn't mean you have to integrate it there. You could integrate it into other hook points in your CI pipeline. You could, of course, always scan it on the side for your entire repository as a different job as well. And you saw how quickly it could run, right? In literally a matter of minutes, the pull request is scanned for and results are available. So compared to incumbent solutions in the market, the developer could literally make the change, like go make a cup of coffee, be back at his or her desk, and the results are available, right? So that's how quickly we do the analysis. And so, yeah, one time a day, multiple times a day, numerous developers working at the same time on the source code, integrating these scans into all of those workflows. It's totally fine. We do that today, and perfectly doable for any environment.
All right, great. Next question. Let's see. Where in the stack does shift left integrate?
Good question. So yeah, primarily we play into the static analysis space. So it is with your source code repository. It depends on the language. So for instance, for Java today, we work off the build artifact. So what we call as the jar file or the bytecode. So for that, we would integrate into the CI system. So as I did in the demo, it is invoked right after the build goes through. For other languages, for instance, like .NET, we integrate into the source code directly, right? So it is part of the build itself is where we would integrate. But primarily it is in the CI environment. So it's either as part of the build or post-build job is where we would be invoked. At the same time, it doesn't mean that you need to have a CI system. Like developers are more than welcome to use these directly on their own boxes or their own test environments. So it doesn't have to be automated. You can manually invoke these tests as well. So imagine it needn't even be a developer. Like we have customers today where security teams do the scans. So they might already have like the build output. They might have like a staging environment. So they have like the application with them, and they might invoke the scan on that. So automation perspective, it's in the CI system. But from a scanning perspective, you could do it wherever you have access to the application and its source code.
All right, great. So we have about 12 minutes to the top of the hour, or 13 minutes to the top of the hour. Plenty of time for questions, guys. So we have a couple questions left here in the queue, but if you do have a question, please go ahead and use your GoToWebinar control panel, and we'll just keep right on rolling until we don't have any more questions to go through. So moving along here, our next question, which languages does Shift Left support?
So the ones that are on the website today for Shift Left Inspect are Java, C#, Scala, and Java Servlet Pages, JSP. And we do have other languages coming out soon. There are some languages we are working with customers on a beta mode, JavaScript and Golang as examples. So again, if those two languages are of concern and immediate need, there are customers who are already using it today. And so again, please reach out to us through the website, and we would love to get you onboarded if it's JavaScript or Golang. If it's any of the other 4 languages, you can sign up for yourself for free on the website.
All right. Okay, let's see. Our last question here that we have. So like I said, if you guys have a question, please go ahead and you get it in now so we can get to it. Do I have to modify my code for Shift Left to work?
Oh, absolutely not. So there are no changes required in the source code, no changes required in the application itself. Like you're not instrumenting, you're not like changing how you build the environment. So you don't need to do any of that. What you do is like for language like Java, as I said, it's a post-build job that you add into your CI. And if you look at our documentation on our website, you can see it literally is a single command that you invoke. It literally says shift left, analyze this workload. That's pretty much it. And it's the same for languages like C# when you integrate it into the build. So again, no source code changes required. It's all in the CI environment. So like Jenkins or Circle CI or any of Azure DevOps or any of those systems where you would edit or add jobs in order to integrate shift left. And it's, as I said, it's straightforward. Most customers that we work with, they are like integrated, onboarded, and start their scans within like 15 minutes. It's that simple.
Excellent, excellent. Okay. Got so many great questions that have come in. So thank you to everybody. I do have one other question that just came in. Thanks, Leon. Does it scan only main branch or all branches of code?
Yeah, so you can scan all the branches. You can scan it at the pull request level. So it's totally up to how you configure your CI system. There are customers of ours today, given how big their code bases is and how many developers they have in the environment, they say, hey, we don't want to go over all of these scans, and our developers are not the ones who are looking at these scans. It's maybe another team. So it depends on how your organization functions. But from a capability perspective, yeah, down to the pull request, down to a branch, at the master branch level, for forked repositories, you can scan any of these. It totally doesn't matter. We support all of that.
All right, great. We just had another question come in. If I find some variable names which shift left does not recognize, then how can we get that dictionary updated?
Perfect. Yeah. So I was mentioning that, yes, you can get the dictionary updated. For how, there's detailed steps in the documentation website. If you look at docs.shiftleft.io, let me pull that up right here. Okay, so that's docs.shiftleft.io. And then here we have shift left inspect. There you go. So inside shift left policies, we have identifying sensitive data leak variables, and then you have full details on how you create the policy, how you validate it, how you assign it. So all of those links, it's all on the website, and it's full details of like what commands to execute, how do you check in, how do you do it. There's examples of how you add variables. So all of that information is here on the website. Just go to docs.shiftleft.io. And one thing to note here, it's a one-time process. So once you have updated the dictionary, it is applicable for all future runs, right? So you're not changing it for every single run. And then it's all at different levels. So you can do it at a analysis level. So you could do it for just one run. You could do it for the entire application for all future runs. You could do it at your entire organization. So this dictionary is applicable for all applications within your organization. So all of these things are possible. And then we also do versioning. So you could have multiple versions of a dictionary. You could invoke them. So it's very fine-tuned and fully controlled by the customer. So it's totally up to you how you want to use it.
Okay, great. All right, so we're about 7 minutes to the top of the hour, and that was the end of the last of our questions. I'm going to wait to see if we get maybe one or two more stragglers in, and while we're waiting, we did promise you at the top of the hour that we would be doing a drawing for 3 $50 Amazon gift cards. So while we're waiting, why don't we go ahead and do that? And our first winner is Adam P. I'm not going to say the last name for privacy reasons, but Adam P., congratulations. Our second winner is Jake R. Congratulations, Jake. And our last winner today is Rudy W. So congratulations to all three of you. We'll be contacting you via email following today's webinar to get you set up with your gift cards. And also, I want to remind the audience that today's event has been recorded. So if you missed any or all of the event, or if you just want to watch it or listen to it again, you will have the opportunity to do so. Following today's webinar, we will be sending out an email that contains a link to today's event, so you can always watch it on demand. The webinar is also going to be living on the devops.com website, so you can always check it out there. Just go to devops.com/webinars, look in the on-demand section, and it will be right there waiting for you. And while you're there, please check out the other webinars that we have, both upcoming and on demand. Hopefully there'll be one or two at least that pique your interest. Well, it doesn't look like we're getting any more questions in. So Arun, I do want to thank you for giving such a great presentation.
Thank you. Thank you for the opportunity, and audience, thank you for all the time that you spent with us and for all the questions. And I hope you would check out the website and register for the free version. Thank you.
Awesome, awesome. Okay, yes, I also want to thank the audience, especially those who submitted some questions. Great questions today, guys. But I also want to thank the audience for joining me today. And this is Charlene O'Hanlon, and I'm giving you 5 minutes back in your day. So have a great day, everybody.